Alright, we're going to prove this trigonometric identity using the addition subtraction formulas, in particular for cosine, because I've got cosine of x minus y and cosine of x plus y. So we're going to begin with the left-hand side, and I'm going to expand the cosine of x minus y first. The trigonometric identity for that is cosine of x cosine of y plus sine of x sine of y. So that's what you get when you expand cosine of x minus y. Then we'll expand cosine of x plus y. So that's cosine of x cosine of y again, minus sine of x sine of y. And now we're going to multiply all of this out because eventually we need these squareds on the right hand side, so the easiest way I can see to do that is to multiply these two binomials out. So when I multiply cosine x cosine y times itself, I end up with cosine squared x cosine squared y. And then when I multiply sine x sine y times negative sine x sine y, I get negative sine squared x sine squared y. And then I need to multiply the inner and the outer terms here. And here we get, in the middle we get cosine x cosine y sine x sine y, and on the outside we have negative cosine x cosine y sine x sine y. So those cancel each other out, so we don't have the middle term. So we're pretty close with this to the right hand side, but not quite. So what I notice when I'm trying to change this into the right hand side is that I need my first term to have this cosine squared of x, so that means that the cosine squared of y needs to disappear somehow. So the only thing that I can think of is to replace the cosine squared of y with 1 minus sine squared of y. And let me remind you of why that's true. We have this Pythagorean identity that sine squared of y plus cosine squared of y equals 1. So that means cosine squared of y equals 1 minus sine squared of y. This is very common. Alright, and then my second term on the right hand side has sine squared of y, which is here. So I'm going to replace sine squared of x using the Pythagorean identity for that. So I've got minus sine squared of x would be 1 minus cosine squared of x, and then I want to keep my sine squared of y. Okay, now I'm going to distribute all of these through. So I get cosine squared times 1, so cosine squared of x, minus cosine squared of x, sine squared y. Then I need to distribute this negative sine squared y through here. When I do that, I get negative sine squared y times 1. Then I have negative sine squared y times negative cosine squared x, which is positive sine squared y cosine squared x. Alright, so now I notice that I have negative cosine squared x sine squared y and positive sine squared y cosine squared x. So those two things are exactly the same, except one's positive and one's negative. So they add up to 0 and drop out. And now we have cosine squared x minus sine squared y, which is the right hand side.